Picture this: you're traveling away from Earth, past Mars, Jupiter, and even Pluto. You keep going. For years, decades, centuries. You'd think you'd eventually leave our solar system behind, right? Well, what if I told you that our solar system is encased in a colossal, invisible wall, a sphere of icy debris stretching out an astonishing 1.5 light-years in every direction? This isn't science fiction. It's a real, mind-boggling theory about the true edge of our cosmic neighborhood. Welcome, fellow space enthusiasts, to a journey to the farthest reaches of the sun's domain. Today, we're exploring one of the most mysterious and massive structures known to astronomy, the Oort cloud. It's a place so vast and so distant that it marks the boundary between our solar system and the great expanse of interstellar space. And the most incredible part, we've never actually seen it, not a single piece of it. So how do we know it's there? Stick around, because the evidence is as clever as it is cosmic. To understand the Oort cloud, we first need to get a sense of scale. Let's start with something familiar. The distance from the Earth to the Sun is called 1 astronomical unit, or O. That's about 150 million kilometers. Pluto, that distant icy world, orbits at an average of about 40 astronomical units. The Voyager 1 spacecraft, humanity's most distant object, is currently around 160 astronomical units away and has been traveling for nearly 50 years. That sounds far, right? Well, the Oort cloud is believed to begin at a staggering 2,000 to 5,000 astronomical units from the Sun. But that's just the inner edge. It's thought to stretch all the way out to 50,000 O, or possibly even 100,000 astronomical units. Let's put that into perspective. At 50,000 astronomical units, you're about 7.5 trillion kilometers away from the Sun. That's almost a full light year. The Oort cloud is so enormous that light takes over a year and a half to cross from one side to the other. Our entire solar system, with all its planets, would be just a tiny dot in the center of this immense, spherical shell. So, what is this gigantic, invisible sphere made of? Scientists theorize it's a reservoir of trillions. Yes, trillions of icy objects, often called planetesimals. These are primordial leftovers from the formation of our solar system, billions of years ago. Imagine them as cosmic snowballs, composed of water, ice, methane, ammonia, and rock. They're basically comets waiting to happen. Most of them are just floating out there in the deep freeze of space, barely held by the sun's incredibly weak gravitational pull at that distance. But if it's invisible and so far away, how did we even come up with this idea? The story begins with a brilliant Dutch astronomer named Jan Oort. Back in the 1950s, Oort was studying comets, specifically the ones with very long orbits. We're talking thousands or even millions of years to go around the Sun once. These are known as long-period comets. Think of Halley's Comet, which visits every 76 years. The comets Oort studied made Halley's look like a regular commuter. Oort noticed something peculiar. When he calculated the orbits of these long-period comets, he found that their farthest point from the Sun, their aphelion, wasn't random. They all seemed to cluster at a similar immense distance, around 50,000 astronomical units. It was as if they were all being flung from a specific region, a shared home base at the edge of the solar system. Furthermore, these comets didn't just come from the same plane as the planets. They came from all directions, above, below, from the sides. This suggested that their source wasn't a flat disk, like the Kuiper belt where Pluto lives, but a vast, spherical shell surrounding the entire solar system. And thus, the concept of the Oort cloud was born. It was a revolutionary idea that elegantly explained the origin of these majestic, long-period visitors. The theory goes like this. These icy bodies in the Oort cloud are usually in a stable, quiet orbit, but occasionally, something gives them a nudge. It could be the gravitational pull of a passing star, a giant molecular cloud, or even the tidal forces of our Milky Way galaxy itself. This tiny gravitational disturbance is enough to knock one of these icy chunks out of its stable orbit and send it tumbling inwards, towards the Sun. As this icy body falls towards the inner solar system over thousands of years, the Sun's radiation begins to heat it up. The ice turns to gas, creating a glowing coma or atmosphere, and the iconic tail that we recognize as a comet. And so, a new long-period comet is born, making a spectacular, fiery journey through our skies before heading back out to the cold darkness, not to be seen again for millennia. The Oort cloud is essentially our solar system's personal comet nursery. This brings us back to the central mystery. If this cloud is so important, why can't we see it? There are a couple of major reasons. First, the objects within it are incredibly small and far apart. While there may be trillions of them, the space between each object is vast. It's not a dense cloud at all. It's more like a cosmic mist, incredibly diffuse. Second, they are extremely faint. They're far from the sun, so they don't reflect much light. Trying to spot a small, dark, icy rock a light year away is like trying to find a piece of charcoal in a dark room from a kilometer away. It's beyond the capability of our current telescopes. So, the Oort cloud remains a theory. A very, very good theory, supported by strong indirect evidence, but a theory nonetheless. We have never directly observed an Oort cloud object in its native habitat. Everything we know is inferred from the comets that visit us from this distant realm. They are like postcards from the edge, giving us clues about the vast unseen structure that defines the true boundary of our solar system. This raises so many fascinating questions. What else is lurking out there in the dark? Is the Oort cloud uniform, or does it have a more complex structure? And what could these primordial objects tell us about the birth of our own planet, if we could ever reach one and study it up close? The challenge is immense. A probe sent today would take tens of thousands of years to reach the Oort cloud, but that's what makes space exploration so exciting. The invisible wall of the Oort cloud isn't a barrier, but a frontier. It represents the profound mystery that still surrounds our own cosmic backyard. It's a reminder that even after centuries of looking up at the stars, we have only just begun to map the incredible scale and secrets of our universe. The solar system isn't just the planets we know. It's a vast, dynamic, and mysterious place, and its grandest structure is one we've yet to lay eyes on. What do you think? Does the Oort cloud truly exist as we imagine it, or is there another explanation for the comets that grace our skies? Let me know your thoughts down in the comments. I love reading your theories and ideas. Thanks so much for joining me on this journey to the edge of the solar system. If you enjoyed this cosmic exploration and want to dive into more of the universe's greatest mysteries, make sure to hit that like button and subscribe to the channel. Your support helps us create more content just like this. Until next time, stay curious and keep looking up.